Okay, so this is day 2, graphing quadratic equations. All right, so let's start the warm-up. The warm-up is what we did yesterday. But before we begin, remember that you're going to need a graphing calculator for this lesson. If you don't have a physical one, you have the option of getting the Graphing Calc application for your computer that I showed you yesterday, or using the free TI download that you can find on our Schoology page to download directly to your computer. Okay, so let's start with the warm-up. So first we need to find the axis of symmetry. And we said the axis of symmetry was an imaginary line that goes down the middle. It always starts with x for axis, and this equation is x equals -1. The vertex is the point that it goes through, the turning point where the graph changes direction. Since that's a point, we use coordinates, -1, 4. Okay, the roots or zeros are where the graph crosses the x-axis. And there are 2 points like there, x equals -3 or x equals 1. You could also write those in squiggly brackets like we did yesterday. Is that a minimum or a maximum? It's a minimum because I can see that that turning point is on the bottom rather than the top. And I can tell that minimum goes down to -4. Okay, so I'm going to use the Graphing Calculator app on my iPad for today, but it's very similar to the TI-83 actual calculator. It's just that I noticed the buttons are in a couple of different places. Okay, so let's move up here. So for model problem A, we're going to graph x squared minus 4x minus 5. Okay, so the first thing that we need to do is figure out where this graph is. And so what we can do there is use the axis of symmetry to do that, because the axis of symmetry, since it's the middle of the graph, will locate where the graph is, and specifically the center of it. So that's going to be the idea. Okay, just get rid of that. Okay, so the axis of symmetry formula we gave you yesterday, it's very important that you remember it. It's x equals -b over 2a. And we get that the same way that we do a, b, and c for the quadratic formula. We get it from right here, the coefficients. We don't need the c, so we don't have to worry about that. So a equals 1, b equals -4, and so we have x equals -4, it's 2 negatives there, over 2 times 1, which is 4 over 2, which is 2. So the axis of symmetry is x equals 2, and what we're going to start to do is draw a line like that. Okay, now we're going to plug that in to find the vertex. Okay, the vertex is where the turning point is going to be on that line, and we know that it's going to have an x coordinate of 2. We just don't know where on the 2 it's going to be, so we're going to plug that in. So if y equals x squared minus 4x minus 5, and I plug in 2, that's 2 squared minus 4 times 2 minus 5. Let's see what we get. 2 squared minus 4 times 2 minus 5 is -9. Okay, oops, not on the graph, so I'll just make some lines down here, and I'm going to put a dot there. That's the point 2, -9. And that's where I'm going to start my graph. Okay, now step 3, I need to create a table of values. Well, here's where the graphing calculator comes in. Okay, the thing about the parabola, if I could just sketch one over here, is that it's symmetrical about that axis of symmetry. And so, besides the vertex, every point on it is going to have a match somewhere else on the graph. See, they're all balanced like this. And so what you're going to see is some repeating y's. Okay, so let's go to the calculator so we can see this. Okay, so that is, where's my calculator here? There we go. Okay, so graphing calc 83, and we're going to go to y equals, okay, and it was x squared minus 4x minus 5. Okay, now a couple of things you might want to do about your graph. First, the first thing you might want to do is check your window to make sure that you're seeing them. So in this case, it's second graph, but on a standard calculator, it's just the window button. So look for the button that says window. Make sure that your window reads like this: x min and x max, -10 to 10, and x scale being 1. Now on a regular physical calculator, this will already be preset unless you were fooling with it. But if not, just make sure that it's that way. Okay, y min and y max and y scale the same thing. On a physical calculator, there's also something called x res. You don't have to worry about that. Okay, now as far as your table, now there's something called table set. Here it's above the word table. On a physical calculator, it's actually above window. So that's why when I'm graphing, sometimes I call this doing your chores, right? What are your chores? You wash the windows, you set the table. Okay, so we're going to set the table, okay, and we're going to fix our windows too. So this is our window. This governs what we're going to see. Now we go to the table, second table here, okay, or just second window on a standard calculator, for the table setup. All right, there's two things. Table start is where the table is going to start. That's the first number you're going to see. You want that set to 0. Okay, delta table, that little triangle, tells you how it goes by. Is it going to go by ones? Is it going to go by tens? Is it going to go by a half? 1 is fine for now. So make sure table start says 0 and delta table says 1. And now we're able to graph. So remember, y equals should read this. Okay, can't see anything without that. And then we're going to go to graph. And this is what it should look like. Okay, so that's helpful to a point, but what we really need is the points that we can write on our chart so that we can graph it. So we're going to need to go to the table. On a standard calculator, that's second graph. That's what we learned, but here it's just a button, so I'm going to go to the table. Now, these are some points that are on the graph, and if I scroll up or down, just like a regular graphing calculator, I can see what points there are. But, and here's the but, the axis of symmetry must be the one that's in the middle. So what was our axis of symmetry? It was x equals 2. So make sure that x equals 2 is in the exact middle. Now what was the vertex? What was the y that went with that? Right, -9. We figured that out. Now we want to put this point in the exact middle. This calculator doesn't seem to have an exact middle because there's, oh wait. There's 7 data points. We should be able to get, no, there's 8. So we're not going to be able to get an exact middle on this one, but on a standard calculator we are. But ignoring that -2, 7 for a second, if 2, -9 is in the middle, look what you notice, right? I see right above it 8, -8, and right below it, -8. So there's 2 -8s. Remember those matching y's I told you about? Okay, and above that, -5, and its partner, -5. There's always going to be matching y's evenly balanced around the vertex. And so above that, here's 7, and below that is 7, always evenly balanced around the vertex. So what you want to do is you want to copy 7 points. That should just about do it. And then just plot them on the graph, and then you're done. So let's do that. Okay, so back to where we were. We want to put the vertex in the exact middle. So 1, 2, 3, 4. Okay, right here. So 2, -9. Let's go ahead and put that vertex there. Then we evenly surround the point. So let's count 3 up and 3 down. And let's copy the y's from our calculator. So it was -8, -8. And it was -5, -5. And then it was 0, 0. And those are the points we're going to copy. So -1, 0, 0, -5, 1, -8. There's my 2, -9. Then back up to 8, then back up to -5, and then by 5 I'm back to 0. And if I wanted to continue, that next point was 7, it would be up here. And then I'm going to make a nice smooth curve like this. And that's how we graph a parabola. Okay, so now we can read off all the things. What are my roots? Right, -1 and 5. Is there a max or a min on this graph? Is a turning point on the top or the bottom? That's right, it's on the bottom, so that's a min, and the minimum is -9. Now find f of 4. Do you remember what that means? Well, that means that x equals 4, and what's the y? So if x equals 4, just looking at my table or my graph, y is -5, that point is also here. Okay, so f of 4 is -5. That's a little bit of old school for you. Okay, and that's basic graphing. All right, there's also something called the 1-3-5 rule, which I'll talk about briefly because I might as well. Going back to what we were doing, what we didn't do yesterday with the rule for quadratics, and what makes it quadratic, all quadratic functions will have the property where once you get the vertex, the points you can get are up 1 over 1, up 3 over 1, up 5 over 1. Okay, here's what I mean. So here is our vertex, right? There we come back. Here we go. Okay, our vertex is 2, -9. Look and see the jump. The jump from -9 is to -8. That's a jump of +1. The jump from -8 is to -5 is +3. The jump from -5 to 0 is +5. There's the 1-3-5 rule. Okay, and so what we'll do is one of these problems will actually do it 1-3-5. It's a way of doing it without the calculator if you don't have one handy. All right, but for now, the calculator is the easiest way to do it, so let's just move on. Okay, here's exercise A. I'm going to let you do that a little on your own. But let's get started. Okay, this is not solved for y at all, so let's move that 10x over. We've got y equals x squared minus 10x plus 16. Okay, pause the video at this time and then do the rest of the problem. We'll come back and go over it. Okay, let's take a look. So in this case, here's my equation. My a is equal to 1, b is equal to -10, And so my axis of symmetry is x equals negative negative 10, that's negative b, over 2 times a is 1, so x equals 10 over 2, which is 5. My axis of symmetry is at x equals 5, so we'll start there. Okay, so when I do my table of values, remember 5 is going to be in the middle. Go 3 up and 3 down, within reason. Okay, let's plug in 5 to find the vertex. So y equals 5 squared minus 10 times 5 plus 16. So let's see what that comes out to. 5 squared minus 10 times 5 plus 16, negative 9 again. Okay, so my vertex is at 5, negative 9. Oh, not very good graph planning. Okay, so there's 5, negative 9. There's my vertex. Okay, actually, if you want to know a secret, you don't actually have to calculate the vertex, because once you know the axis of symmetry, you can go right to the calculator, right? Let's go there again. Okay, so here's graphing calc. I'm going to go to y equals. I'm going to clear off what I did before. I only want one at a time. So it's going to be x squared minus 10x plus 16. And I don't want to go to graph. I want to go to the table because I need the point. Now, what was my axis of symmetry? You see, if I'm not on the axis of symmetry, you see how there's no patterns in the y's. They're just going, well, in this case, they're going down if I go this way, up if they're going this way. They're just going in one direction. We absolutely don't want that. We want the matches. We want it to go down and then up, or in some cases, up and then down. But we need to have matches. So we need to have that axis of symmetry showing. And what x was it? X equals 5. So there's the 5, and there's the negative 9. That's my vertex, but it's not supposed to be on the end. It's supposed to be in the middle. So there's the middle, and there are the points again. All right, and so I'm going to copy those points from 2, 0 to 8, 0. Okay. All right, so here's 2, 0. And 3, negative 5, down to negative 8, back down again, back up again, 7, 8, okay? And there's my curve. Graphing is literally as simple as that when you have a graphing calculator. But I did want to show you how to graph with the 1, 3, 5 method. You don't have to erase yours. I just want to show you. Okay, now, to graph with the 1, 3, 5 method, and this is completely optional, we start by making a table. I write the letter A over here, and 1, 3, 5. Now, what is A in this case? A was 1. We got that back from there. So it's just going to be times 1, or 1, 3, 5, which means I'm going to go up 1 over 1, up 3 over 1, up 5 over 1. Okay, from the vertex, I'm going to go up 1 point over 1 point. That's going to give me my 6, negative 8. And then to the left, up 1 over 1 to the left, and that's going to give me my 4, negative 8. Then from that point, okay, I'm going to go up 3 over 1, moving in an outward direction. So 3 from here, 1, 2, 3, out 1. So that's going to be my 7, negative 5. And then from this point, up 3, out 1. That's going to be my 3, negative 5. See, I'm getting the same points. And then from this point, up 5 over 1. And then from this point, up 5 over 1. Again, moving in an outward direction. Clear some of that up. Okay, so up 5 over 1 brings me to 2, 0. Up 5 over 1 here brings me to 8, 0. And that's the 1, 3, 5 method. Okay, but the graphing calculator works perfectly fine. But just some of you who want somewhat of an easy method, you have that as an option. Okay, so my roots, what are my roots? Where are my zeros? Well, you notice, as we said before, where it crosses the x-axis, right? Also, the y is 0. We said that that a 0, or a root, is where the y is 0. So that means it crosses the x-axis, and those numbers are 2 and 8. Okay, is this a max or a min this time? Right? It's a min. It's on the bottom, and that's -9. And f of 4 is -8. Okay, just looking to see how much we have going. Okay, I think we'll do one more. Looks like my battery's about to run out. But this is just one that goes upside down. And how do we know it goes upside down? Because of the negative number in front for A. A is -1 in this case, which means it's going to be a frowny face. But no matter, it's still going to be the same procedure. So let's start. My A in this case is -1. My B in this case is -2. So x equals -2 over 2 times -1, which is 2 over -1, which is -2. That is where, no, 2 over -2, sorry, which is -1. Clean that up a bit. Okay, +2 over -2, -1. Axis of symmetry is -1. Okay, now, watch. I promised you didn't have to find the vertex algebraically. You can do it graphically, as long as you know that -1 has to be in the center of your table. Remember? The calculator will actually give you what point belongs here. Let's just fill in 3 more. This is what our table should look like when we're done. So, off to the calculator. I forgot what it was. Okay, okay. Okay, so this time, let's clear that off. Make sure you're using this negative, not the blue one, the gray one. -x squared, now blue, minus 2x plus 3. And if you just look at the quick graph, right, the graph is a frowny face, and that's always going to happen when A is a negative. So let's go to the table. Wow, what happened? I don't like that at all. So this is where table set becomes important. Go to second table for the table set. Why it's starting at 58 all of a sudden, I don't know. But we'd like it to start at 0 and go by ones. And so I should go to table and it's fixed. Phew, that was close. Okay, but my axis of symmetry is -1. And so that should be in the middle. And you notice how that point is different from every other point? Look, every other point should have a partner, right? 3 has a partner here. 0 has a partner here. -5 has a partner here. Okay, but 4 is the only one that doesn't. So that's how you know it's a vertex. So, -1, 4 is the vertex. And those are the points that I'm going to capture. Okay. So, let's go back. And let's copy that table. Vertex is -1, 4. And then we're going to go this way. So, you already know that I can graph by just copying those points and call it a day. But now let me show you how the 1, 3, 5 rule would work if you choose to use it. So I'm going to make my A table with the numbers 1, 3, 5. Now, in my previous example, A was equal to 1. And so it was just up 1 over 1, up 3 over 1, up 5 over 1. But if A is not 1, you have to multiply the numbers 1, 3, and 5 by whatever A is. And in this case, A is -1. And -1 times 1 is -1. Times 3 is -3. And times 5 is -5. And so, from my vertex, -1, 4, I'm not going up 1 over 1, up 3 over 1. Where am I going? I'm going down down 1 over 1, down 3 over 1, again moving in an outward direction, and down 5 over 1. And that's how I get the upside down. Okay, just to check off the points, it'll work the same way. There's my vertex of negative 1, 4. This is 0, 3, and negative 2, 3. There they are. This is 1, 0, and negative 3, 0. Check. And this is 2, negative 5, and negative 4, 5. So it doesn't matter which way you actually do it, you will be getting the same thing regardless. I just wanted to show you that. Okay, connect, and then we're all done. Okay, so my roots, negative 3 and 1 in this case. My maximum, because it's on the top, is 4. That's how high the roller coaster goes. And what's f of negative 3? Oh, looks like 0. It's one of my roots. And so when x equals 3, y equals 0. Okay, so I will put the answers to exercise B, okay, which will be an independent, in a media album. I will post it in the folder. So you can do that one independently so I can end the video. And then your job, of course, is to do the independent practice and homework. Now, if you have a printer, I do recommend printing out at least these few pages so that you have access to the calculator. Access to a graph. If you don't and you'd rather use graph paper, you can actually just use graph paper. But please don't try to do it freehand. It just doesn't make your graph look nice. So if that's at all possible, do use graph paper or the graphs that I provided here. Okay, and that's it for us today. Thanks, guys. Bye-bye.